Full screen mode. All right. Okay. All right, guys. Thank you so much for joining the session. I think you heard about me. There was like a lot of things were exaggerated about me. I'm not doing so many things. I'm doing very small things, bits and pieces of things to understand the construction industry and architecture in general, right? Yes, I started with the architectural education, heritage conservation, and construction project management. And I moved into relational contracting, integrated project delivery, as well as construction safety. So I'm actually in a mix of many things and doing bits and pieces everywhere in construction research right now. In terms of teaching, I'm focused on innovation and business process engineering and re-engineering of construction business process, how we deliver things as a construction business, so how we operate in an industry. So I'm looking into that area as well in terms of teaching as well. So coming back to the topic, safety, climate, and construction. I'll be very brief, and I'll be giving you a very generic overview of how we see things. We have done some research on safety climate. Some of the research actually was in 2017, a collaborative work, and some of the work is being published now. I think we'll be sharing one or two things from the current work as well. But most of my work actually is on the consultancy side. So we have been I've been working with Professor Steve Rollinson on construction safety. So we work with the contractors and with different organizations, subcontractors, for improving their safety in general safety management system, right? So we have been conducting some surveys with the construction industry. We did actually a couple of surveys before, and we are in the process of actually doing that thing as well. So obviously I cannot share that particular work here because of the confidentiality thing, but we'll be discussing in general about a lot of things actually. So if you have any question, you can just drop your question in the message box and I'll be happy to answer you, right? But in presentation, I'll be very brief in explaining. Right, so a brief introduction, safety climate, theoretical models and frameworks. What are the generic theoretical models we follow, like in terms of safety climate, what we are and what we do, and what are the best practices? And in conclusion, simple thing, right? So it's nothing scientific kind of a thing, right? Very simple explanations. Now, we have seen occupational health and safety as a major concern for developing economies. Look at Hong Kong, look at Malaysia, look at Thailand, look at Pakistan, look at India. Almost every single developing economy has an issue with occupational health and safety. There are issues with the legislation. In the first place, there is no legislation. Or if there is some legislation, there is a poor enforceability of legislation and the law. And there are ambiguous safety performance targets. People are not clear. People are saying that, oh, our target is to get a zero accident, zero injury, zero incident on site. But at the end of the day, we have so many accidents, so many incidents, injuries, so many things. So these are the common issues you can find in almost every single developing economy. What it does is actually, it is leading towards injuries and fatalities in construction sites. I can name so many newspapers now in Hong Kong. From last couple of years, we have seen an increase in the construction injuries and fatalities. a major increase. So this is a number actually from Housing Department of Hong Kong, and it does provide a generic overview of construction industry. You can see from 2012 to 2022, in the last 10 years actually, the number of accidents per 1,000 workers in construction industry, which we can see here, are going down from 44.3 to 29.1. Fair enough. Should be a good sign, right? It should be a good sign that is decreasing and the number is going down and down consistently. And this number is actually the red lines and the green lines, which show the housing authority works actually. So if I give you a brief introduction, the housing authority works is more of a public housing in Hong Kong. So housing authority is responsible for public housing, and there's a major construction work going around the housing authority projects. So they have a maintenance works going on, and they have a new projects as well. So that's why they have compared, and this figure actually is from them. And they have compared with the overall construction industry. Generally, they are doing fine, perfect. They are doing well, actually, if you compare with the other contractors or other participants of an industry. But in general, things are not good. Still, we see construction-related fatalities are among the highest compared to other industries. Construction-related fatalities are among the top, if you look at the occupational and safety, health and safety numbers in other industries, right? So this is actually a reference to a LegCo paper, Legislative Council paper, which presented the number actually, how worse construction industry is performing in terms of safety. And we can see the similar number in other developing economies. If you compare with Malaysia, if you compare with Pakistan, if you compare with India or any other developing economy, we'll have a similar number. So this was actually reported in newspapers as well, like in Hong Kong Free Post. It was reported that in 2022 alone, 13 deaths were occurred related to construction. And there have been many cases, many cases. So there were actually a major tower crane accident in construction, and 3 people died, and more than 6 people are injured on construction site. There were many other accidents on construction sites where people died. So this 13 number is actually reported from 2022 as well, and is being common nowadays in construction industry, especially in Hong Kong. We hear a lot of news about accidents in construction sites. I don't know what's the reason. They are still looking into these things actually. What are the reasons for these increasing number of accidents? So what should we do? Should we just sit down, forget about everything, or we should focus on the root cause? A lot of people believe, and research has suggests that workers' unsafe behavior is actually a root cause of construction injuries and fatalities. Unsafe behavior of construction workers. And why we are blaming construction workers actually for this thing? They are being affected, and again, we are actually blaming those guys who are actually doing the work. That is your problem, is your unsafe behavior actually. So we started from here, and a lot of research actually focused on physiological conditions such as fatigue and stress during construction work, individual qualities such as communication, if they are being able to communicate with others about the safety issues, safety related things or not, if they can learn well or not, and competence issues. So we have been discussing about this, and we have been researching these issues. One of the important issues which we have been working recently is actually worker engagement nowadays. Worker engagement, the way we actually define it and explain is the engagement of on-ground worker, which is actually on site with their immediate supervisors and the management. So if the construction laborer is working on a construction site, if he's able to communicate, is able to engage in safety related discussions with their immediate supervisors, safety related issues with their supervisors and the management of the project or not. So that is actually one of the key issues these days, which we have been working on actually. Another issue is actually safety knowledge, if they have the required knowledge and skills or not, safety behaviors, compliance and participation behavior, culture, and last but not least, climate. So we have been working on these issues for a very long time. So why we have these kind of issues again and again? Why we face similar kind of things again and again? Because there are loopholes. We do not implement things properly. Simple as that. So safety climate, if you look at the definition, safety climate refers to the shared perception and attitudes, and beliefs about safety within a workplace. In construction industry, it plays a vital role in promoting and maintaining safe work environment. How safety climate can ensure a safe work environment? I'm unable to understand. Can anyone tell me? Can anyone help me understand how safety climate ensures a safe work environment? Any idea about it? Anyone? Can anyone tell me? Nope. All right. Safety climate reflects the support from the top management and the supervisors for effective implementation of the protocols and motivates workers to prioritize safety while executing tasks. So what we do is actually when a construction worker is working on site, usually in construction sites, they are motivated, they are in pressure to finish the task. I don't know if some of you have been working in a construction contracting firm or construction contractors or subcontractors. The ultimate objective for the contractor is to finish the job. Finish it, and finish it. That's it. I've worked on construction sites. I've been on construction sites for very long hours, actually, from mornings till evening, right? The main concern on day-to-day basis is whether we have achieved a target or not in terms of completing the work. Yes or no? Not even a single contractor I've seen in my personal work experience who cared about safety. So that means there is no safety climate. Nobody cares about safety. But if the management and the supervisors who are supervising your work deeply care about the safety and implementation of safe work protocols, that would motivate workers to work safely, and that would create a safe work environment for every single person working on a construction site, right? Now, this prioritization helps workers to manage psychological and physical challenges while dealing with the safety hazards. Obviously, when they're not in a pressure or they're not under pressure to finish the job or get the job done, no. If they're not under this kind of pressure, they can focus on work with a different mindset that, okay, we have to work safely, no matter if we are delayed for 1 minute, 2 minutes, or 1 hour, or 1 day. Doesn't matter, but we have to work safely. So that kind of attitude we are looking into actually in terms of safety. The safety climate plays a pivotal role in reducing job demands, yes, and increasing workers' efficacy, motivation, and intention. So if we do not put too much pressure on construction workers to get the job done, no matter what, they'll be mindful, they'll be careful when they are performing their job, they are performing their work, they'll be careful, and they will care about each and every single person working together with them. And that's how we develop a safety climate on the construction site. Now, this is actually old figure, and but I really like this one. I'm really inspired from this one, and it tells us how things work actually in terms of safety climate, how safety climate works, and how it influences behavior. This research is actually from hospital context. This is not related to construction. This research on safety climate, by the way, safety climate is not only in construction, but it's been used in several other industries. And it's been used from probably last 4 decades. So it's not a new term as well. And it's very much common in hospital setting as well. Safe work environment when we are in operation theater or even in any other environment, in hospital environment, right? So it suggests that safety climate influences the adoption of safety behaviors. Just give me a second, guys. I think there is some problem. Dr. Mimi, can you hear me properly?
Yes, Doctor.
Okay, fair enough. Because I was getting some kind of noise, so that's why I thought. Okay, no worries. Okay, let's continue with that. So when we look at the safety climate here in this figure, it suggests that it influences the adoption of safety behaviors. How safety climate influences the adoption of safety behavior? We just explained it. And it influences co-workers' behaviors as well. Ultimately, it leads to the safe work environment and increased perception of a safe environment. So, can anyone tell me what will happen if we have a perfect safety climate? What will happen in construction site, in your office, in any work setting? In a simple words, if people are comfortable, if people are confident that we have a sound safety climate within our workplace, it will change their behaviors towards their work, how they perform their job, and it will influence their co-workers' behavior, and ultimately it will influence their mindset and attitude that, okay, we are working in a safe working environment, and that's why we have to be mindful about this thing. So again, this is a very old figure, actually, framework from hospital context, but it's very much relevant in construction industry, and it's still relevant actually. Now, again, we are coming back to the Zohar's work on safety climates. Probably the most celebrated author on safety climate in organizational and a group setting. So if I receive some paper for review from any journal, and which is on construction safety, and they haven't cited Zohar work, I would probably think they haven't done it. They haven't completed the research. So he is one of the founding individuals or researchers who contributed greatly in a safety climate research. So what it suggests that organizational safety climate influences group safety climate, and then it influences behaviors. What do we mean by organizational safety climate? And what is a group safety climate, by the way? We just mentioned the safety climate, right? And why safety climate and safety behavior? What are these things actually? Organization safety climate refers to our organizational approach to deal with the safety related issues. When we are talking about a group safety climate, we're talking about individual teams. Okay, let's take an example of construction site. We have a scaffolding teams, we have a concreting teams, we have a excavation teams, we have so many other teams, right? Finishing teams, interior design teams, floor concreting, structural team, so many teams, right? When we are working in a construction site, so many different teams, and each has their own protocols, their norms and practices for working in a certain environment, and they follow certain protocols with regards to safety that are influenced by organizational safety climate that are in practice. So every single construction business or construction company or contractor company, let's say, in simple words, they develop their safety management system in a climate which is influencing individual groups' safety climate, and then ultimately reflected in safety behavior. So Zohr's safety climate scale is generally used, the construct or a scale is used for safety climate measurement in research, which is actually further simplified with a shorter version as well. So it helps us measure a safety climate in a group or organizational settings, right? Now, coming back to our research, actually, this research has been led by Dr. Hassan Ashraf, and this paper is actually accepted by Engineering, Construction, and Architectural Management. I think it's under typesetting, so it'll be available online soon. So we completed this work a bit earlier, actually, but it was in a publication process, so it took some time. This framework actually suggests that safety climate influences safety behavior. Fair enough, but through the articulation of safety knowledge and systematic problem solving. What is safety knowledge articulation, and what is problem solving, system problem solving, and what is safety behavior here? Okay, let's say the safety behavior is same, participation and compliance. But what is safety knowledge articulation here? The safety knowledge articulation is actually, okay, if I put it in a lay terms, right? In a lay terms, is organizational routines and practices which are conducive to externalize detective knowledge sharing through collective efforts. Okay, in construction projects, when we are working on a construction site, we have some key people such as foremen, safety ambassadors, and senior professionals on safety. They roam around on construction site, they visit, they talk to people, they discuss issues, they discuss a lot of things with people on construction site. They actually mentor people. They mentor construction workers on site. What they're trying to do is actually creating an environment where the safety knowledge can be articulated and can be used in a collective way, so that it can develop a conducive environment for discussion and application of safety knowledge. So it again leads to the systematic problem solving. Once they are actually articulating the safety knowledge, they can use it systematically in order to solve issues, in order to solve the loopholes in the process, discuss it informally, and ultimately it leads to safety behavior of construction workers, which is compliance and a participatory behavior as well. So we can see that safety climate is actually ultimately leading towards safety behavior. And through different approaches, we saw 2 or 3 different frameworks from Zohar's framework, which we saw that safety climate is actually influencing organizational level safety climate is influencing group level safety climate and then ultimately safety behavior. We saw the previous work in hospital context that safety climate influencing safety behavior. We saw in this context that safety climate is influencing safety behavior, but through the mediation of safety articulation, safety knowledge articulation, and systematic problem solving. Why there are differences? Why we have so many differences here? Initially, it was perceived that the safety climate and safety behavior is a direct relationship. If the safety climate is in place within a construction organization, it will ultimately or it will directly affect the safety behaviors of a construction worker. So you just need to take care of safety climate in construction contractor, and it will ensure that the behavior of workers on site is fine, perfect. But things doesn't work in a simple way. We have seen actually from our consultancy, one of our consultancy work, actually, we have seen the contractor organization, I won't name it, they had a safety climate in place. They had a safety management system, safety climate, and things were perfect. And even then, they got several issues, injuries and accident on construction sites. So again, they were in a fix that, okay, we have things in place. Why things are going in the wrong direction? Again, they contacted us and discuss about how we can actually look into these issues. So we are looking into these issues, how actually safety climate translate through the safety knowledge articulation and systematic problem solving towards safety behavior. So it is not a direct relationship. Again, there may be a direct relationship, but the effect of that relationship is not really strong, significantly strong, if we look in the research terminology, right? Now, in a recent study on safety climate, in a recent study of safety climate, Syed Yahya reviewed 162 papers from 16 different industries. So safety climate studies from 16 different industries. And they concluded that the safety climate is highly related to safety performance or safety behavior. Yes, we know that thing. Yes, it is related, but the relationship may not be that strong if we have a direct relationship. And safety climate is also known to ensure a safe work environment. I think we discussed it in a very old research from 2000 in a hospital context that yes, safety climate ultimately ensures a safe work environment on a construction site or in a hospital setting, right? So what are the determinants of the safety climate? How we can explain safety climate in concrete terms? We said that there is the management support and commitment, supervisor support and commitment to motivate others to do something, blah, 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 blah. Yes, we said that thing. But what are the exact things of our safety climate? How we can measure it, safety climate? How we can understand it? So we have a first actually dimension of a construction safety climate from Wool's research from 2015, which prioritize or which focus on a safety priority. Safety is a priority for a construction organization, contractor organization as a priority. So don't we prioritize safety? The question is, if they say this is important, That means that we are not prioritizing safety right now. It's not. What are we doing? Safety supervision. Don't we do supervision on construction site? Don't we provide safety training to construction workers? Don't we communicate with the construction workers about safety? What are they saying? Safety rules and procedures, safety involvement. What are they saying? Don't we do these things? We do it, right, in construction site. Yes, we do these things. But the level of implementation of these things, the level of priority which we keep on the safety may not be that high. Okay, again, I'm giving a simple example here. We, as a contractor or as a subcontractor working on a construction project, if they have a choice between finishing the job on time and working safely, I'm 100% sure they'll prioritize on finishing the job on time. Right? Again, about the supervision, safety supervision. You can find several examples in Hong Kong, several examples where supervision was not adequate or not properly done. And when you're talking about involvement, people who are really doing the job, they are not part of the discussion about safety. So again, these are important things which we have, but some of these things are not implemented well enough. We have another work from Zahur. I think I'm a co-author here in this paper as well on a safety climate study and building projects actually in Hong Kong. I think this work was completed in 2017-16 probably. He identified management commitment and employee involvement. Again, the similar things. Safety enforcement and promotion, safety rules and safe work practices, safety consciousness and responsibility. Again, similar things. So why we have a same thing or similar things coming again and again about safety? Safety climate and construction from New South Wales government, Australia. Safety priority. Don't we prioritize safety on a construction site? Organizational safety learning. Don't we provide training to the staff? I think in Hong Kong, if you are actually working on a construction site, you're not allowed until unless you have completed certain level of training, even as a visitor. So when we usually visit on construction site for collection of data, we interviewing people for our research, we have completed a certain level of training, green card training, in order to enter and visit the site as well. So different levels of trainings are provided to people on a construction site at a different level, right? Again, supervisor safety practices and co-worker safety practices as well. So these are some of the things which we actually focus on in safety climate. Now, the Construction Industry Safety Climate Index. Again, this index is actually developed to measure safety climate of a contractor organization, which again focuses on the similar things. I don't think we should repeat these kind of things. There's a commitment and concern of organizational health and safety by organization management, resources for safety and effectiveness, and personal involvement, safe working attitude and workmates influence, and so on and so forth. So these are the generic things which we have to be mindful of, right? Yeah, sorry. So which we have to be mindful of. But why we have a similar things repeating again and again, and we are not being able to implement them properly? Because each organization, when we are working in a construction firms, their approach, their attitudes towards safety are different. They think safety differently. again, I'm not contradicting the policy implementation. Actually, there is a policy, policies are being implemented, but the level where the policy is being implemented is actually different on construction site. So although we have a literature which suggests several conceptualization of safety climate in construction businesses actually develop their tailor-made safety management system to address organizational needs, their needs based on their focus, their priority, their safety priority, how they think for the safety, if the safety is important or not. Some focus on safety as a building for life, living injury-free every day, which is a philosophy related to safety, care for life, and life-saving rules, and so on and so forth. There are several examples. They develop their tailor-made safety management system in order to address the needs of organization. And they do it actually. We have seen several examples actually in our consulting work. So some of the best practice which they adapt actually, there is a leadership commitment. They appoint safety ambassadors on construction sites. These are the people who are actually working on a construction site. They are general foremen. They are the safety officers. They are engineers. They are managers on a construction site. They act as ambassador at the different levels of a construction site in order to motivate, nurture the juniors with regards to safety, right? They provide safety trainings, yes, which is very common. They have a safety stand downs, discussion about safety on day-to-day basis, safety huddles, which is very much common in Hong Kong right now. Safety huddles, stand downs, and a pre-task planning for every single task. They plan about safety as well. Near-miss reporting, I think that is very much common, near-miss reporting and incident investigation as well. So they follow different approaches in terms of dealing with the safety practices and implementation of their safety management plan or safety management systems. Now, but we discuss so many things, right? We discuss about a couple of frameworks. We discuss about some of the accidents. We discuss about some of the management systems or best practices. But why are we doing all this? What is the need for safety? Why we need all these things, right? Why we all need? The only reason is we want to complete our project successfully. That is the only thing. And that's why creating a positive safety climate is essential for success of any construction project. Because if you want to make sure that the project is successful, you need to have a positive safety climate. And we have seen leading contractor companies in Hong Kong and around the globe demonstrate that if you have a strong commitment to safety at all levels of organization, so not just at management level, not just at engineering level, not just at site or in worker level, we are talking about bottom level where people are actually working on a construction site. Coupled with the effective safety management systems that can significantly reduce workplace accidents and foster culture of safety, ultimately leading us to the success. So this is actually very much important, that commitment towards safety at all levels. We have seen that people are saying, construction contractor organization, when you talk to them, their general managers, their site managers, their project managers, when you talk to them, they talk about safety all the time. They say we implement this and that, we have this kind of system, we have this kind of system, we have this approach. But when you look into the projects on the actual construction site, you really see the gap on the construction site where people are actually working on a construction site. You really feel the gap there. So if you have a strong commitment towards safety at all levels, that can help us actually reduce the incident, injuries, and accidents or fatalities on construction site. I think that's all a very brief introduction from my side. Any question, concern, anything, just let me know. I'll be happy to answer. Thank you so much.
Yeah, thank you so much, Dr. Shoeb, for your enlightening presentations and very interesting topic to be highlighted. Now, we would like to open the floor to our students. If you have any additional questions or insight, please raise your virtual hands or type in the chat, okay?
Sure,
Is there
sure.
any questions from the floor?
Hello, doctor. Can you hear me?
Hello. Yes, I can hear.
Hello, Dr. Shoeb. Thank you for the lecture. My name is Zakiri Musa. Based on your presentation, what I come to understand is this safety climate issue is all about the support from top management. But my question is how we measure the support, this managerial support, how we measure it? Is it by we see this management doing all the best practices indicates that the management has doing the best safety climate in construction environment?
All right. Okay. There are different ways to answer this question actually. If you ask me in terms of research, I can tell you that this is the safety climate questionnaire. You need to use it to measure it. That's it, right? In terms of research. But when you're talking about safety management climate and management support, we need to see how engaged management is actually about the safety issues, and not just safety issues in terms of meetings and discussion in boardrooms. We're talking about engagement in construction related activities and discussion on site. When we said safety huddles, stand downs, safety huddles, stand downs, and safety ambassadors on construction sites. This is actually reflecting that management is serious about safety issues and they really want to ensure that down on the bottom, things are being translated, or the vision or the mission is actually going down to the bottom and people are really caring about safety. So you can see management support and commitment from the trainings as well, how often they provide trainings, and you can see regular hurdles, stand downs on the construction sites. You can see real engagement from the management on construction site. That is where you can really see if there is a safety climate in place and construction on it. Okay.
Yeah, yes, I understand. But what I have saw in our country context, normally, let's say we have 100 million project, a value of project. But then when the management maybe has put aside 1% of the value to do the safety issues lah, to control all the safety. So is it the 1%, let's say for 1 million out of 100 million value is considered a best effort for measuring the performance of the contractor?
There is some voice issue. Okay. So this is one of the ways actually to tell that we care about safety by investing in safety, by investing money. Okay. So one of the issues, right, or one of the approaches to tell that we care about safety, and that's why we are investing in safety related issues, right? But this is not enough. When we are talking about safety climate, when we are talking about safety real effect of a safety climate on the construction site, this is not enough. You need a personal involvement from the management. So I'm not talking about a CEO is coming to the site on construction site on a day-to-day basis and looking into safety issues. No, it's not their job. It's not his job. I'm talking about the project managers. We're talking about the management of a project. Are project managers or the site managers, general managers, which are actually involved in the project, are they really involved in the process or not? So what happens? Okay, when I was working on a construction project, actually on a heritage conservation project, which involved some of the new construction and heritage preservation. So what I used to do I was not a project manager per se, but I was the lead on the project for that particular site. So what I used to do is actually, I used to visit once in the morning when I was coming to the site office, and I was visiting, taking a round of whole site, visiting, talking to people, informal discussion about any issues, like if they have the issues, one in the morning, one in the afternoon, and one before leaving the site, before finishing my day, actually. So at least 3 times I was visiting the site, talking to people, talking about generic issues. So similar kind of approaches when we are actually going to the site, talking to people, discussing about their safety related issues or how they are performing their job, what are the issues related to their work, and how they feel about safety related issues. That is actually really reflecting how engaged you are. That is reflecting engagement actually from workers to supervisor and the management. That is where we are looking. So investing money, yes, it is important, yes, but it's a one way to show that we are actually caring about safety. Okay.
I think we have one more question from Mr. Nur Nikman.
Yes.
Hello, hi, Doctor.
Hello.
My name is Nikman Saleh. By the way, I would like to say thank you for the presentation, for the excellent presentation just now. Number one.
It was a very simple one.
Two,
sorry.
Number two, the best practice was excellent. Actually, in my point of view, the one who really should ask a question is my colleague Muhammad Shafiq. He has very good knowledge in safety. On the other hand, I would like a few questions. I would like to ask a few questions. Number one, my question is there any different best practice in safety in Hong Kong compared with mainland China? Because your Hong Kong and China is side by side. Is there any differences? We would like to understand about.
Okay,
to know more
so
about that.
I can comment on Hong Kong safety approach and how they manage things, but I may not be familiar. I know a bit about it, but I'm not very much familiar with the mainland practice actually about safety. Yes, Hong Kong has a very robust safety management system. Each organization there is a generic legislation, right? Legislation regarding occupational health safety, and construction industry, there are specific regulations, rules, and policies which are in place for the construction industry. And every single contractor organization which are working in construction, they have their safety management system in place, right? They have their own safety management system in place. They look into their safety climate, their safety culture, and their engagement on construction engagement with the workers on construction site on the day-to-day basis, actually. So yes, it's a very robust system. And for mainland China, I think there are some differences because of the cultural differences, a bit of a culture and a bit of a different exposure, because Hong Kong was a special Hong Kong is a special administrative region, and there is a difference in culture as well, right? And especially in the construction industry, things work in a different way. So I can only comment on Hong Kong, but I think there are differences, but I may not be very much familiar with the mainland practice as well. So apologies for that thing.
Right, thank you so much, Doctor, for your input. And I think it's very delightful to have you today. Before we end this session, I would like to invite everybody to open their camera, and we have a photo session for memory. Maybe we can have a next collaborations next time, yeah, with Dr. Shoeb. Okay.
Thank you, Dr. Mimi, right?
Yeah, sure.
Okay, thank you so much. And that was a very brief, actually, overview. I was not very much familiar with the structure because it's the very first time for me to participate in a master lecture style of, right? So I try to be very brief and generic about the discussion. I hope you like it, and hopefully we'll conduct the next session.
Yeah. Yeah, hopefully we can still keep in touch.
Yeah.
And for the students, maybe you can just email or contact Dr. Shoeb for any question related to the safety climate.
Sure, anytime.
So,
I think my
yeah.
email is available, right?
Yeah. So, Mr. Zailan, Shafiq, are you guys ready? Okay. Okay.
Thank you.
Okay. Can you guys give a big smile? Okay, 1, 2, 3, smile. Okay, this first. Okay, one more. Very big smile. Everybody say cheers. All right, thank you so much, Dr. Shoeb. So, I hope that maybe we can invite you for another session or another semester for a collaborative teaching again, because in UiTM we have that collaborative teaching. We inviting outside speakers, sometimes from industry, from other university, to give a different point of view, because it is something that we can share through a worldwide view of the safety understanding throughout the education transfer knowledge. Thank you so much, Doctor.
Thank you, Dr. Mimi, and
See you
thank you for
again
inviting
next
me. Thank you.
time.
See you.
Bye.
Bye.
All right, so I believe Dr. Akilu is here already. Akilu? All right, okay, Doctor. Let me make you as a host so that you can share your slide. Let me give me a second. Okay, I've already made you as a co-host. Can you try to share your screen? Yep, we can see your slide.
Okay. Good afternoon, everyone. Can everyone hear me?
Yeah, sure, Doctor.
And you can see my slides.
Yes, Doctor.
Okay. Yep, sorry.
Okay, so I think before we proceed to the lecture series, I would like to give a little bit of your background. Is that okay, Doctor?
That's absolutely fine.
All right, okay, Doctor. So let me introduce myself. Myself is Dr. Mimi. I am from the architecture department, UiTM Sri Iskandar Perak. I am on behalf of the Dr. Mazlina Zaira. Would like to say thank you to you because you're spending your time, your knowledge here to share with our students. So before we begin, I would like to introduce our esteemed speaker, Dr. Akilu Yunusa-Kaltungo. Am I correct? Am I pronounce your name correctly?
Yep, that's fine. Yeah.
Okay. All right, Doctor. So, Dr. Yunusa is currently serving as the discipline head of education in mechanical and aerospace engineering at the University of Manchester. He has taken on the role amidst extraordinary circumstance, navigating the challenges posed by the COVID-19 pandemic and over recruitment of students. And he's also have extend beyond the successful implementations of online and blended learning. He has effectively managed teaching resources, nurtured relationship with the professional bodies such as the institutions of mechanical engineers and the Royal Aeronautical Society, and spearheaded improvements to the mechanical and aerospace engineering programs. His also initiatives include enhancing the MACE programs and units by addressing the lack of crucial elements in management safety, reliability, and sustainability through the collaborations with college and also developing an optional unit on engineering, safety, and reliability management, and restructuring the Master of Science Aerospace Engineering program to offer more optional units providing students with diverse learning opportunities. And he is also actively involved in research and publications activities, which is serving as a lead guest editor for special issues on sustainability in operations management and green buildings and energy sustainability. His contributions to professional engineering practices extend to his role as a member of the IMEC Safety and Reliability Working Group, a reviewer for international engineering standards, and certified industrial health and safety auditor. Now, without further ado, I would like to invite Dr. Yunusa to deliver his lecture sharing and share his valuable insight with us. And after the lecture, there will be an opportunity for the question and discussion, so that you're free to actively participate to all the students. Yeah, thank you, and let's warmly welcome Dr. Akilu Yunusa-Kaltungo.
Thank you very much, Mimi. So thank you for the introduction. Yes, most of everything about me has been said. Just to add, my fundamental research background is condition monitoring of rotating machines using vibration signals. However, I did spend 10 years in the industry prior to joining the academia. So, and while I was in the industry, I was health and safety manager, I was maintenance manager, I was training and development manager, and I was a project lead. So by virtue of my industrial experience, I was able to bring a lot of those into the academia, especially the aspect of safety. So a lot of people do see reliability as a mathematical and very technical field. However, if we look back at the history of reliability, we would all understand that reliability and safety are almost one and the same thing. As a matter of fact, reliability and asset integrity and things like that originated as a result of trying to improve operations under a safe condition. So the title of my talk today is a reliability-based approach to learning from engineering failures and successes in construction. Now, everything we do in terms of trying to improve safety culture, safety climate, design for safety, and averting failures all circles around our ability to learn from previous experiences, either experiences that are related to ourselves or from other people. Like they say, wise people learn from other people's success or mistakes, okay? So not all of the lessons must happen to us. Nothing stops us from learning from other people. And that way we're able to avert catastrophes at their incipient stages. Now, this lecture kind of feeds into the collaborative work we've done with your institution in Malaysia, with Professor Khairi, Maslina, and some of my other colleagues at the University of Manchester. So, just a second. Yeah. So what do we hope to achieve from today's lectures in terms of learning outcomes? So the essence here is not to go into the deep nitty-gritties of reliability-based safety approach, because it's an entire body of knowledge. But I mean, we're just trying to introduce the concept and see the possibilities of these being applicable to construction safety. Because what we found is reliability-based approaches, as well established and as useful as they've proven to be in high-risk industries like aviation, like nuclear, and so on and so forth. the application within construction have been significantly limited, despite the generic nature of these tools. So the first learning outcome today would be to try and understand the fundamental principles and features of learning from failures and successes. People say it's easier. There are arguments for and against whether learning from failure is more effective or learning from successes. I would say both need to be combined. Of course, failures leave a deep scar and probably makes people remember more because of the costs that have been associated in terms of resources and lives. But again, if we adequately optimize lessons from successes, they could have an almost equal effect. But we need to be very focused and committed to that, because when you succeed, then it's very easy for you to forget because the outcome from success is mostly positive. The second learning outcome would be to understand the fundamental principles of using reliability engineering-based tools to learn from design failures through vital case studies. So I've put in 2 case studies here. One is the Hurricane Katrina disaster, and the other is the Grenfell Tower disaster in London a few years ago. I think it was 2017, if I remember correctly. And about 70 people or 74 people lost their lives. Hurricane Katrina had a far more devastating effect, as some of you would have recalled from that incident. So before we delve into the actual lecture for today, I would just want you to look at these questions. Now, do not bother about the rightness or the wrongness of your answer, but just give it a go. And we would definitely revise what I consider my solutions at the end of the lecture. So let's pick the first question. I've called it brain teaser. Okay, and I don't want you to tell me your answers now, but just note down your answers, what you feel your answers are. So these are the answers. What I would expect you to do is, for each question on your piece of paper or on your device, for question 1, you just write if the answer is A or B, just 1, you put B by the side, or C, or whatever you think is the right answer, and do that for 1 to 8. Note, some questions have more than one answer. Okay, so I'll just give you the next 1 minute to do that, and then we shall proceed into our lecture. I know perhaps some of you are familiar with some of these tools and have some of the fundamental knowledge. For C, Ishikawa is also known as fishbone diagram. Okay, so some people might be used to Ishikawa, some people might be used to fishbone diagram, and some people might be used to both. Okay, so we've got 1 minute. Just note down your answers, and we shall be reviewing these at the end of the lecture. Okay, are we all happy to proceed? If you just let me know if you're happy for us to proceed, please. So Mimi, am I good to go?
Yes, Doctor, please.
All right, thank you. Yeah. So just a brief introduction to learning from safety experiences. Now, we do know accidents are very unpleasant occurrences because of the incredibly expensive and damage associated with them to both human lives and property, which further emphasizes the need to investigate every incident that occurs either within our organizations or other organizations through reports or personal experiences. So detailed and effective accident investigations can offer a means of proactively discovering what could go wrong. What we don't want is humans by nature are reactive. And this is why sometimes, even when you're given up to a year or 6 months before exams, you still find yourself circling back to your revision a week or 2 weeks before the exam. Just because of our reactive nature, some of us feel that our output and productivity is at the highest when our deadline is very close to us. Now, with regards to safety, we cannot or should not be taking such approaches because of the potential costs associated with these in terms of life. You should remember it's almost impossible to place a price on life, no matter how young or old whoever it involves is. So all facets of engineering and management need to develop a strong capability to systematically delve deep into root causes of accidents. So root cause analysis, causal effects, and safety, reliability, integrity studies are very much associated with a lot of terminologies. But again, everything can still be looped under the heading of root cause analysis when we're talking about learning from failures. In order for us to get the best out of our learning process, and not only in terms of learning from failures, learning in general, the more systematic we are in our approach, the better we're able to document our steps and findings, which makes it very easy for us to trace back our paths, or for someone else to trace back what we've done in the past, so as to identify the proficiency of our outcomes or where improvements should be made. Okay, now the design stages of engineering processes offer some of the greatest opportunities to incorporate crucial lessons, because at the design stage, when we go through the life cycle of assets or construction, we find out that, in any life cycle, if we take the birth top curve, for example, the operational phase is the stage that gives the highest opportunity for the asset owner to recuperate what they've invested into that project or into its design, which means you want to minimize failure to the minimum. The only way you can minimize failure to the minimum and in turn optimize your profitability is by making sure that you design safety you put safety into your design, which is what is commonly referred to as DFS, or design for safety. And not only does it optimize your ability to make profit during the operational stage, but it also makes you proactive. So you're able to foresee some of the things that could go wrong right before you expose people to that infrastructure or that asset. Okay. Now, although several tools and techniques are available currently in the literature in practice, but we still find out that failures still happen. So we will need to ask ourselves, why are we not learning? Or on the other side of the spectrum, why are we losing the knowledge we've learned previously, which is what is referred to as unlearning? A very good point to build upon from your last presentation, which I caught a little bit of. I observed that the speaker was speaking about safety culture, safety climate. A very important aspect of safety climate, besides management commitment, which is very key, which I saw that he emphasized so much on, is also the ability of individuals within an organization to be able to voice opinions without fear of reprimand. Now, and every organization that has a very healthy safety culture, you would find out that people within that organization are not afraid to report their mistakes. Now, and this again comes back to how much the management encourages this kind of practices. If people are afraid that they're going to be reprimanded if they say something they didn't do well, then the natural inclination is for people to hide errors. When people hide errors, the person that hid the error might, of course, get away with it, but then that error or hazard remains inherent within that organization or that place of work. And consequently, someone else becomes exposed to it, which of course will still lead to an accident, a near miss, or an incident. Okay. Now, I'm going to show you a very short video about that just shows some of the usefulness of learning from failure. It's a very short video. It's related to the aviation industry, but let's not forget a lot of safety initiatives started from the aviation industry, high-risk industries, we call them, aviation, nuclear, and so on, and military, and so on and so forth. So they have a lot of foundation knowledge in this field of safety, reliability, and so on and so forth. Some of it might be things you've heard before, but it's just, I put this in there. It's just a short 2 to 3 minute video to kind of put us back into the realm of safety and how things are done in other places. All of the things that will be talked about are directly replicable into the construction industry. So it's not because it's an aviation example, it has to stay in the aviation industry. Okay, so please let me know. I'm just going to play a little bit of it. I'll pause and ask if my audio is being shared. Okay.
A message from the Flight Safety Department.
Can everyone hear that? Mimi, was that audible?
Yes, we can hear that, Doctor.
Okay, thank you.
How can we learn from incidents? You are having coffee with some of your colleagues, discussing and laughing about a mistake another colleague of yours has recently made. You say, "Did you already hear the latest story? How could he have done that? I mean, okay, no blame, but this was really too stupid." Think for a minute. Do you have the tendency to react that way? You still think, if only he had reacted in a different way, and you are convinced you would have reacted in a different way. Whilst it is easy to point the finger at somebody else, what if one day the finger is pointed at you? Would you not want to explain what really happened, to be understood? Because you did your best, it was logical to do it that way. You were right with it. The goal of a Swiss Air Force flight safety investigation is to do precisely that, to find out what really happened, and why it made sense at that moment, rather than pointing the finger at any individual. This is what we mean when we say we're committed to a learning culture. Think about it. The Swiss Air Force is a high-risk organization. Hundreds of employees ensure high-risk missions during 24 hours, 365 days. As a worker in the planning desk, on the tarmac, in a truck, or as a pilot in the cockpit, all of us do the very best we can to fulfill the mission. However, we don't always succeed. Why? This is what the Swiss Air Force Flight Safety Investigation helps us to find out. Contrary to a legal investigation initiated by the military justice, the purpose of a safety investigation is not to find the guilty, but to understand why it made sense to you, and to learn from your view to make the system safer. What exactly do we mean by that? Lesson 1. Don't put the blame on individuals. Ask questions to understand. If people get blamed for their mistakes, the only thing one achieves is that people will keep their knowledge about mistakes, safety gaps, or dangerous situations for themselves. Ask why, like a mantra, to get deeper and deeper to the cause. To put yourself into the actor's shoes and to understand why the event had happened. In fact, a key element in our safety culture is to talk about mistakes without fear of punishment. The General of the Swiss Air Force himself reaffirms his commitment to fight the blame culture and publish this commitment in the flight safety policy. Lesson 2. Learn from experiences and make your job safer. Mistakes or incidents can be seen as free lessons. If we fail to learn from them, other colleagues will fall into the same traps, because the holes, safety gaps, are still there. Please support the management's safety effort and ask for a flight safety investigation to help you formulate a report whenever you experience an event that you think offers an opportunity to learn. And remember, the goal of a flight safety investigation is never to stop the Air Forces from flying. The goal of a flight safety investigation is to enable that the operations can take place with an improved margin of safety, and to save all the available assets we have, to save you. You can make a difference. You're the expert. Please send...
Okay, thank you very much. one of my most, one of the parts of this video that I like the most is the essence of safety, implementing safety is not to stop operations. Okay, I know a lot of it is about flight, you mentioned there, but like I said earlier, all of these messages can be transposed into any industry. So the essence is not to stop operations. So the essence is not to make people feel like they've been punished because you want to implement safety. The essence is to ensure that, because without operations, you will not make money. And without making money, there will be no need for even having the operation in the first place. So whatever actions you're implementing must be justified in terms of cost and in terms of the risk you're trying to avert. So this is why things like hazard and hazard operability are implemented and introduced. So the aim is to ensure that your operations can progress under the hazards available. So operating within hazard, because no matter what you do, you can never have 100% hazard-free work environment, but you need to put in things in place that would ensure that people are safe to work within those inherent hazards. Okay. Now, what are the fundamental reasons for engineering design failures? So there could be more categories, but I feel there are two main categories here. So one is inherent weakness, and the other class is victimization. Now, victimization could be in terms of the equipment or the tools you're using for work, or it could be in terms of victimizing the structure or the asset itself. So let's look at some of the classification. Inherent weaknesses. Are you going for cheap option because you want to cut cost? We see this a lot. People go for cheaper option and compromise quality. Okay. Poor design execution. So the option might be correct, but if it's not adequately designed, so the raw materials and everything might be the right ones and in the right proportion, but if the execution of the design is poor, you'd still have a poor outcome. Okay. Substandard material. This is self-explanatory. The manufacturing process. Are you manufacturing to the right tolerances, or are you using the right fits, and so on and so forth? Now, let's look at victimization. Now, victimization has two further categories, which could be functionally, so during functioning, or physically. So let's look at some of these. So poor installation, again, could be as a result of victimization. Poor commissioning. So you've installed the equipment, you've got the right equipment, which was made with the right material, installed correctly. But then commissioning. We all know commissioning. I used to be a commissioning engineer when I was in projects. And commissioning, depending on the size, the cost, the criticality of the assets, can take months or even up to a year to commission. And what you do during commissioning is you apply steady load and observe the reaction of that structure or that asset to each of those loads or service condition. So you're meant to be going gradually. Maybe you start with 5% load. You run it for an hour, run it for 2 hours. So a lot of commissioning engineers sometimes become impatient and decide to speed up the process, especially when you're dealing with things like concrete. So I worked in the cement industry. We have what we call early strength. We have what we call 28-day strength. And then we have what we call long-term strength, which could take up to 365 days to form. For those of you with background in the cement industry, you know that cement is basically made of clinker, which contains things like the C2S, C3S, and so on and so forth. C3S is mainly responsible for 28-day strength, which is what you test in the lab to certify the cement. But the C2S contributes significantly to long-term strength, which is, I make a joke with some of my friends when they're building. And, you know, when people erect their buildings, sometimes they get to the lintel level before they roof it. Maybe they've run out of funds. They leave the building for up to a year or even more than a year before they gather some other money to come and roof it. And what I tell them is, actually, you've implemented a very good strategy, because by leaving that building, the brickwork, for up to 365 days, you've actually allowed the C2S to gain water from rain and so on and so forth, and allow it to achieve its full long-term strength, which takes up to 365 days. So unknowingly to them, they've stopped their construction because they've run out of funds, but then they're gaining the advantage of allowing the C2S to kind of fully materialize, okay? Now, you also have mal-operation, so operating equipment above their specified limits, or even structures putting load more than the specified safety limits for loads. Then you have change of intent. Change of intent refers to when you're using a particular asset or infrastructure for another purpose other than what it was actually made for. So sometimes you have things like bearings, you have things like couplings, which are supposed to be used. Maybe, for example, you have flange couplings, which are supposed to be tightened to a certain tolerance limit. But because you want to attach something else to them, you use another limit, or you use a wrong bearing because you've run out of a particular type of bearing. So all of these things affect the structural integrity of our assets. Then you have modification. You change things, you modify. This happens very well, even in our homes. Sometimes you want to modify your homes and then you break certain parts of walls. For example, a very common one is the connection of moving from traditional separated kitchen into open plan, and then you break the partition wall between your dining and your kitchen without considering that if that wall is an original load-bearing member, you've automatically compromised the structural integrity. And not all of us seek the attention of structural engineers before we implement such changes. So all these have to do with them changing intent or modification without change management processes. And then on the physically, you have deterioration and then you have damage. So deterioration could be as a result of the asset staying too long in your supplier's store and it's not being properly protected. So for example, if you use steel or iron-based materials, you're meant to protect them maybe with grease to prevent them from coming in direct contact with rain and air, which could lead to rust or corrosion. So it will lose some of its strength even before you put it in service. And then you have even in your organization, so it might leave the supplier store early, but if it stays too long in your organization without the required protection, that could also compromise its integrity. We've left it for too long in service, or it's not properly maintained. Like we know, maintenance is associated, a lot of industrial accidents in construction and several other industries is associated with maintenance processes, which is why when you look at safety certification courses like NEBOSH or IOSH and so on and so forth, a lot of emphasis is being placed on maintenance or facility management activities. Okay, I've talked about protection. And then when we go to, you could also be damaged during protection. Damage also, it could be maybe properly coated or properly wrapped. But then if it's being transported on a road that is poor and it's being subjected to vibration, we know the vibration, if an equipment or a spare is being subjected to vibration over a very long period of time, that could lead to fatigue failure. You won't see it physically. There could be some inherent cracks or some wear and so on and so forth as a result of those vibration during transportation. Again, it could be damaged during storage, like we spoke about, installation, during commissioning, or even during operation as well. If you want to make too much from your assets in a very short time, you could subject it to undue wear and degradation. So these are some of the main classes, and you would find out most of the failures we have related to assets, structures, or tools can be classified into one or more of these classes. Okay. Now, at the heart of all of these classes, you have humans and the organization involved in there, because don't forget, it's people that would install these assets or tools. It's people that would commission them. It's people that will operate them. It's people that will store them. It's people that will transport them. It's also people that will manufacture them or select the materials for their manufacturing. So so the human nature, and this is why in safety and in integrity or reliability studies, the humans are always considered the weakest link. If you can adequately solve the issues associated with people, then you would probably solve up to 90% of the problem. Okay. Now, how do we solve the problem with people? The easiest answer most of the time is through training. But then there are two elements to training. You need to train people and then give them the opportunity to retain the knowledge they've been given. And the only way people retain the knowledge they've been given is if they, one, the training must be adequately and competently delivered, and two, the organization must give them the opportunity to implement the skill they've acquired from that training, or else they'll just hold a certificate, but then they do not have practical knowledge, which is as good as every time they need to do that activity, they are doing it for the first time, which does not really reduce the hazard profile. Okay, and so you have things that the organization brings, which is the training is provided by the organization, the opportunity to practice is provided by the organization, and the support and guidance is provided by the organization. On the side of the individual themselves, the individual has to have the right attitude. An attitude could be classified as either self-limiting belief, so believing you can do something, or believing you can't do it. And the second part of attitude is whether you're willing to do it or willing not to do it. Okay. And then aptitude, which is another factor associated with the person, is whether they are physically or mentally capable. We need to assess, for example, if you have people on construction sites, if the physical part, you don't want people carrying things that are way too heavy for their weight, because even if they don't drop it to injure someone else, they could injure themselves. So they could strain their backs, they could develop some musculoskeletal problems, and so on and so forth. And mentally, people need to have the right level of understanding of the training you want to put them on, or else you put them in a panic mode. When people are in a panic mode, they're unable to function, or they become very prone to errors. So you want people to be not in their comfort zone, because in comfort zone, they don't develop and there is no challenge, but they should be in the stretch zone. Stretch zone is between the comfort zone and the panic zone. And this is where continuous improvement happens. Okay. So whenever we're developing trainings, we need to take into account the attitude of the people we're putting on training, the aptitude of the people, and then we need to make sure that the organizations provide the right support for them to implement that knowledge. So on that note, we will be moving on to I'm going to talk about two main tools today as a result due to the restriction of time, and also based on their proficiency, their popularity, and their versatility. So the first is fault reanalysis, and this method provides a systematic or visual description of various causes of a specified system failure. Okay. It consists of gates. So for those of us that are very familiar with Boolean algebra, it works with gates. We have AND gates, we have OR gates. OR is usually associated with components that are connected in series. So failure of one leads to the failure of the entire system. And the AND gate is usually associated with parallel connections where you have redundancy. So for AND gates, the two components or the two stages connected must fail together for that failure to occur. So an example is in your aircraft. An aircraft will most aircraft will have 4 engines, 2 on the right side, 2 on the left side, but you need 2 to function at the same time. So the other 2 are functioning as pairs. However, the aircraft configuration is a bit complex. It's not just any 2. So you want one from either side of the wings to function because of aerial stability. Okay. Then it's one of the most common engineering design quantification technique, and you can use it either as a qualitative or quantitative technique. If you have failure probabilities over a historical period of time, you could do quantitative. If you do not have that, you can also use it as qualitative. It's also very good for proactive or for investigative. So if it's a failure you don't know anything about and it's happened, you can use it to investigate what are the reasons for that failure. If it's a failure that has happened before, then you can put all the elements of that failure together and use it to predict what causes that failure and when it's likely to happen again. Okay, So, so you take, and the way it works is you take a failure mode. For example, you want to say maybe an accident happened, maybe a bridge collapsed. So bridge collapse is your failure mode. And then you come down, you can decide to have several branches. Maybe you have one branch as the human, you have another branch as the material, you have another branch as the manufacturing process, and so on and so forth. You come on the human. On the human, you can have one branch, you call it maybe knowledge, or you can say aptitude, attitude. Under aptitude or under attitude, you could say, okay, maybe lack of training or maybe poor training. Under training, you say trainer competency, not adequate, or maybe training cost. You went for cheap training option, and you keep going down. And that's why it's called a deductive logic approach. You keep going down until you get to a point where you cannot go down any further. And at that point, you come to what we refer to as the basic event. Once you get to the basic event, then you've gotten to the root cause, okay? If you don't get to the basic event, what you have is symptoms, just like you have in Apollo type root cause analysis. Now, it's usually used to detect failures, and here are some of the guidelines. So here are some of the things to know. No miracles, okay? If the normal functioning of an engineering design propagates a fault sequence, then it is assumed that the design functions normally. A very good example of this is you have things like the jackhammer, which you use to vibrate and remove water from concrete pores, okay? That equipment is designed to vibrate. It is functioning, its function, its normal functioning or its normal mode of achieving its objective is through vibration. So when you're designing a fault tree associated with that kind of equipment, you cannot have vibration as a failure mode. I hope this is clear, because it is designed to vibrate, okay? But then if you have another equipment, maybe like your car, for example, if your car begins to vibrate, then you know there is a problem. So vibration becomes a failure mode for that kind of scenario, okay? And that's what I mean by these no miracles. Complete the gates. The two most commonly used gates, like I mentioned earlier, are the and the or gates. There are other gates like undeveloped events, like the diamond gate. If you don't have enough information at the time in which you're constructing the fault tree, the diamond gates can be put there, and it's used to signify that you do not have accurate or adequate information for that particular branch, and it stays there until you get more information. Then you can complete your fault tree. Complete the gate. So define all inputs to a gate before you develop any one undertaking. Do not connect a gate to a gate. So you cannot have and connected to or and to and. After a gate, there has to be intermediate events before another gate, okay? You see a physical illustration of this. Then the other tool, so fault tree, as said, by default is used for finding the reasons for failure. Reliability block diagrams, on the other hand, is used to determine the reasons for success. What would make a system or a project or whatever it is to succeed, okay? And it's similar to the fault tree, and they're in fact interchangeable. So you can convert a fault tree into a reliability block diagram and vice versa. But when you're converting a fault tree into a reliability block diagram, you only use the basic events to conduct the reliability block diagram. Why do people, so here, sorry, I have two case studies, which at your time you can look at. These are historic events. You can see this one had up to 1,100 fatalities, this one 72, this one up to 300 billion in terms of total cost, and so on and so forth. So take your time to look at them. They're on different scales. This is a building and so on and so forth, okay? Take your time to look at it. In the interest of time, we will not go too deep into this, but then I'll show you how we've used this information to investigate the reasons for failure using fault tree and reliability block diagram. I also have several publications on this. If you just go on Google Scholar and just type in my name, you see a lot of my articles related to this. If you type my name and just put fault tree analysis or reliability block diagram, you see several articles, okay? So for the Grenfell Tower disaster, which I denoted as GTD, this is what, based on the information you had on the previous table, this table on your left column, This is the fault tree, okay? So IA is the intermediate event 1, intermediate event 2, and these explains them. So this is an AND gate, which means that this and this must occur together simultaneously for you to have this event. If this happens alone, then you still don't have that. And then it keeps breaking down, and these A1, small A1, and so forth the circles are your basic events. And once you get to these circles, that means you've completed that branch. And if you want to convert this event, this activity into a reliability block diagram, these are the ones you would use. So for example, A1 and A2 are connected by an AND gate. And we've said AND gate is responsible for parallel connections. So A1 and A2 will be connected in parallel, okay? And in parallel also to A3 and A4. On this side, A5 is connected in series to IA6, which means everything coming from IA6 will be connected in series to this. So A6 and A7 will be in series and in series to A5, but A6 and A7 will be in parallel to this. Okay, don't worry if you take your time and look at it. It's a very, if you go step by step, you would catch the gist quite easily. Now, one thing I'm going to mention is why do you need to convert a fault tree into a reliability block diagram? So this is the fault tree I showed you earlier, and this is its corresponding reliability block diagram. So you can see A1, A2 are in parallel to each other because of these AND gates. A3, A4 are in parallel to each other because of this AND gate. And A1, A2 are in parallel to A3, A4 because of this AND gate, okay? If we look at A5 to A7, they're all in series because you have A5, A6, A7, they all have OR gates, and that's why they're in series. But they're in parallel to A9 and A8 because A9 and A8 are connected in parallel, and so on and so forth. What this means is, why do you convert fault tree into reliability block diagram? Because fault trees could get very complex. If you're looking at a very complex failure, a complex system, you could have up to 50, 60 pages of a fault tree and becomes very difficult to manage. And with the fault tree, it's very difficult for you at a glance to tell which of your connections is the most critical. So when you convert to reliability block diagrams, you can instantly see where we call it your areas of resilience and your areas of vulnerability. Any area that you have parallel connections are resilience, because it's just like having in your house, you have the grid power and then you have a generator. Okay, these two will be connected in parallel. So if you lose the grid power, your generator can also provide you with energy. Okay, if you lose your generator, your grid power is there to give you. Just like the spare tire in your car, you have 4 tires functioning and you have a spare in your trunk. If one of those 4 tires fails, you have your spare to replace. So that is resilience, okay? And that's associated with parallel connection. Series connection, what it means is if A6 happens or A6 fails, this whole branch fails because it's a series connection. It's just like a chain. If you lose one link in a chain, the whole connection is compromised. I hope that is clear. Sorry, I'm moving a bit fast. I'm just being conscious of time. And this is the other example for the Hurricane Katrina disaster. Similar methodology. This is the fault tree, and this is the associated reliability block diagram. It's exactly the same methodology. B1, B2, B3 are all in series. B1, B2, B3 are all in series because of the OR gate, but they are in parallel to B4, B5, B6. So B4, B5, B6 are connected in series because of this OR gate, but this whole branch that carries B4, B5, B6 is connected in parallel to the branch that carries B1, B2, B3. And that's why you see this whole one is in parallel with this. So IB3 contains B1, B2, B3. So IB3 contains B1, B2, B3. And IB4 contains B4, B5, B6. IB4 contains B4, B5, B6. So IB3 and IB4 are in parallel, which is why you have this and this in parallel. I hope that is clear. Okay. And now we've looked at fault tree, we've looked at reliability block diagram, and there are other tools as well, like the YY analysis, the Ishikawa, they're all continuous improvement tools, and they can all fit together depending on how deep you want to go. If it's a very critical error, because fault tree, reliability, block diagrams, event tree analysis, bow tie analysis, these are very, they could get really complex and very mathematical. Sometimes we even use things like Bayesian network analysis to analyze them because on machine learning, because of the complexity and the number of information that come into it. But if you're dealing with a very simple process, a simple failure, then you can use other activities. You could use YY analysis, you could go through your brainstorming. So, but all of these tools can fit together, okay? So first you need to map your process and understand where everything lies. You would definitely need the flow chart or the plant layout or diagram. Then you benchmark your process stages to standards and best performance. You can look at best performance within your industry or best performance within the, if there are no best performance within your industry, or maybe you're the best, then you look at best performance in other industries. So for example, if you compare yourself to other construction companies and you're doing better than most of them, nothing stops you from comparing yourself to aviation industry, because they have a more stringent safety requirement. If you've matched the aviation industry, then you go into nuclear and so on and so forth. And this is what we refer to as continuous improvement. And you could do this using scatter plots or control charts to mark your areas of deviation and areas of success, just like you do in Lean or Six Sigma and so on and so forth. Okay, then once you start seeing deviations, then you begin to brainstorm. You get your experts that know about the process, you put them together and tell everyone to give you their ideas. Remember the video. So you generate those ideas, and those ideas will lead you to your failure modes, which you can now use to construct your fault tree or your reliability block diagrams. Okay. Then you would have several failure modes and several faults. Some of them are critical, some of them are not critical. So you can rank them based on severity, probability of occurrence, and so on and so forth, using very simple tools such as Pareto analysis. Pareto is also referred to as 80-20 analysis, whereby we believe that 80% of our failures are caused by 20% of our assets, and so on and so forth, okay? And then once you've determined the highest ranked failure modes, then you focus your attention on those, okay? And then you select the appropriate tool. It could be fault tree analysis, YY, fishbone, or Ishikawa, failure mode and effect analysis, reliability centered maintenance, and so on and so forth. Reliability block diagrams, there's so many of them. And then generate your corrective action, which should again feed back into your benchmarking process for improvement. And that process needs to carry on. You need to go on and on and on. And I've put a paper there, which if you want, I can send the title of the paper, of the article to Mimi, if you want further reading, and so on and so forth. So that takes us to what are some of the barriers to learning from experience. One is lack of clear procedures for investigation. So sometimes we just get people together and just ask them for their opinion. That structure or systematic nature or systematic nature is very crucial if we want to have traceability, okay? Approaching all investigations in the same way and with the same level of resources is a very bad approach. One, it is not cost effective, and two, it could lead to further failures. So you shouldn't invest the same amount of effort as into investigating a critical failure or a non-critical failure, which is why that aspect of prioritizing using things like Pareto analysis is very crucial. Once you've classified them and identified the most critical failure modes, then you apportion the appropriate amount of resources. So you don't waste people's time, because when you put too much on people, then they become disconnected, and then they begin to cut corners, and you don't get the required resource and the required outputs you want. Failure to gather all relevant facts and information prior to the commencement of investigation. Some people rush investigations just to tick the box. That's a very wrong approach, and which of course is linked to concluding the investigation too soon. Some people do investigation just to have a paper trail. that is not wrong. Poor communications of lessons learned. So some people put the required amount of effort into investigating failures, but then they do not communicate the outcome of that investigation to their workforce, which one makes people feel that their efforts is not appreciated and the management is not really taking on board what they've suggested. And two is the larger workforce does not learn from the outputs of that investigation. Okay, lack of structure again, little or no reporting of accidents and near misses. And then also when you over-report, you give people too much information and they do not have enough time to analyze or diagnose the information you give them. It will again lead to more failures. Okay, so I'm just going to show a flow chart linked to kind of over-reporting and some of the controversies associated with that. Okay, and some of the things you should consider. So when you complete a task, an investigative task or construction task or design task, you need to report what actually happened versus what you thought could have happened at the beginning. Okay, and then you need to analyze the deviations. Why is our actual different from our planned? Okay, now why are you doing this? Is it just to comply with procedure, or is it to improve performance? Okay. Sorry, I think someone is in the waiting room. Okay. Now, will the data be used in the future? Or can we define improvements? So these are the questions you need to ask people and yourselves. Okay. Who does the reporting? Will it be the work crews? Will it be the supervisors? Will it be the team leads? Will it be the managers, the supervisors, or the workers on the shop floor? Do we have enough staff to cope with the reporting load? Are they competent enough? So aptitude, are they willing? Do they have the right attitude? Do they have any hidden agendas? Do they want to sabotage the system? Okay. How do you want the reporting to be done? Will it be electronic? Will it be written? Or will it be verbal? Again, you need to classify if it's depending on the criticality of the information and your ability to use the outcome of that information in the future, or whether you have similar information in your system. You need to determine whether it will be electronic, written, or verbal. Okay. Computer data is out of sight if you choose electronic. Okay. Handwritten data requires manual collation, which could lead to more errors. Okay. Where will the reporting take place? Will it be through face-to-face meetings, or will it be via computer terminal? You need to remember, meeting takes time and requires a lot of people. So if you estimate the amount of man hours of the people you're putting in a meeting every single time you want to do a reporting exercise, you need to make sure that what you're doing is worth the amount of effort you're putting in. If you're choosing computer, you need to remember that once someone puts something into computer and goes away, you can't really ask the computer why this was put into you. Computer is garbage in, garbage out. So if the information put into the computer is inaccurate, the outcome you would get will be inaccurate consequently. Okay. What will you report? Will it be formal data report? Will it be reporting by exception? Or will it be discretionary? So reporting by exception and discretionary is when you give people the opportunity to report based on their experience, and they will make a judgment to report what they feel is important and what they feel is not important. Okay. Now, too much of information could overload the system and then slow down your reaction. And when your reaction is slowed down, then you're not tackling all of the inputs that have been put into your system, which means you might be overlooking some things which could lead to catastrophic failures. On the other side, if you put too little information, then you might not have enough to draw a conclusive recommendation. Okay. When will this happen? Do you want it to happen as soon as possible? Do you want it to happen daily? Do you want it to happen weekly, monthly, quarterly? Okay. Reporting takes time. You need to consider that. And when you leave it too long also, then people might be forced to report from memory, which could lead to faulty or erroneous data. Okay. So let's go back to our brain teaser. I'm just going to show you what I think the correct answers are, and then you can compare them to what you initially selected. Okay. I'll just give you 10 or 15 seconds so that we can move on to, I'll just wrap up the session. on the last slide. Okay, anyway, you would have this slide, so you can always make reference to this at your own convenience. Okay. On that note, what have we covered during this afternoon's lecture? We've looked at the fundamental principles and features of learning from failures and successes, individual and organizational barriers to learning from the past, reliability engineering-based tools for learning from the past. Okay, thank you very much for your time and for listening. I'm sorry I had to rush through the session. It's a very involving topic. Okay, thank you very much, and I'm happy to take a few questions if the time will permit.
Thank you so much, Doctor. So actually, I would like to express my deepest gratitude to you for sharing your invaluable expertise and research with us today. For me, it is very, very interesting methodology, which, if I'm not mistaken, previously when I did my PhD last time, I used to read on the TFA method, but when you explain this now, it's clearly understand, because when I read through the journals or thesis, it's quite difficult to understand how they apply that method. This is really, really helpful for future research or journals write up later on. All right. So without further ado, is there any question from the floors? You open up the question, please. Everyone, is there any question?
I think there's a hand.
Yeah,
Zachary.
Zahiri, Mr. Zahiri.
Hello, hi, Dr. Akilu.
Hi.
Hi, thank you for the lecture. My question is, based on your sharing knowledge, you share that the both accident Katrina and the other one accident too, the analysis you are using FTA, right?
Yes. Sorry.
So what?
Sorry, can you take that again? Sorry.
Now, based on your explanation for the Katrina hurricane event,
yes,
and the other accident, the analysis you use FTA analysis.
Yes.
Why FTA? Why not the other analysis method?
So you see, with FTA, because of its systematic approach, so if you look at FTA very well, it's like a tree. Okay, it's like a tree. You're starting from the root, okay, and then you're going to the branches, you're going to the stalk until you get to the leaves. So the leaves is what we consider like the basic events, which are the root causes. So it takes you systematically through. Now, for Hurricane Katrina, Grenfell Tower disaster, to construct the FTA, there has to be the initial accident investigation where the investigative team, because what the investigative team gives you is a report on what happened, when it happened, how many people were involved, what happened first. For example, Grenfell Tower disaster, somebody left a fridge and on a socket, and then the socket blew up, overheated and blew up, and then caused fire. But then that is what led to the accident, right? But that was not exactly what killed the people. Okay, people were killed because sprinkler systems were not working. There was only one staircase out of a 40 or 50-story building. So escape route was very difficult, and a lot of people were trapped. The fire service system could not access the building because there was only one staircase, no external staircase. So all of these things you cannot put together unless through a diagrammatic approach. So this is one of the reasons why I personally prefer fault tree analysis, because it gives you a systematic, and you can easily go back through the tree to see where you need to improve the quality of your information. And because FTA becomes very complex with a lot of inputs and a lot of data, we convert into reliability block diagram just to make it easy, and you can see the areas that are most critical for you to focus on. I hope this answers your question.
So the weightage for each event done by computer software or manually?
So this is that's the answer to that is a function of how critical the event is and the amount of information you have. If you have a very complex system, for example, I remember when I looked at the fault tree analysis for Concord air disaster, which happens several years ago, or the Chernobyl disaster and so on, and those very big disasters with a lot of information, they become very complex. Some of them could run into 40, 50 pages, you know, so it becomes difficult to manage manually. And that's why we use things like decision support systems. We use artificial intelligence or machine learning approaches. We use Bayesian network to kind of run the simulation for you. So it's a function of the criticality and the volume of information you have.
Okay, thank you, Doctor, for the answer. Thank you very much.
You're welcome. Yeah.
All right, is there any question? Is everyone okay? All right, I think it's very interesting and very clear explanation, Doctor. And actually, I would love to learn more about this method. Hopefully, we can have more collaborations in the future. Maybe go into 1 to 2, 3 case studies or examples so that you can see how it works. For me, it's very interesting because it is something that I've used to read before, but this is the way how you, but the way you explain it very simple and it's easy to understand. Doctor. All right, so I think our lecture series for today is to the end of the session. So can we, before we dismiss, can we have a photo of all of us? But before that, Doctor, can you
stop sharing, right?
Yeah, stop sharing. Yeah. Can everybody open the camera? Okay. Can we have a big smile, everyone? 1, 2, 3, smile. Okay. Please stop first. Okay, can we have one more shot? Okay, everyone can say cheese. All right, thank you so much, everyone. Thank you so much, Doctor, for your input. And then thank you so much for to all the students for the cooperations today, for today's lecture series. Hopefully we still keep in touch, and maybe in future we can have more collaborative teaching like this. Maybe you can have with the architecture students, since this is for master student engineering students. So hopefully in future we can still have this connections. All right. If anyone don't have any questions so far, so I think hopefully we can see or meet you in future. So thank you so much, Doctor. Once again, thank you so much for your insightful thought and also knowledge and experience sharing with us. Thank you so much to everybody, and have a good rest for today, because everybody, I understand that most of you guys are working during the day.
Wow.
Okay, thank you so much, everyone.
Thank you.
Thank you.
All right.
Bye.
Bye.
Thank you, Doctor.